So, very good evening to all. I hope my voice is audible to all of you, right? So, please confirm me once so that we can start with today class. My voice is audible to all of you? Yes. And also, my screen is also, I guess, visible to all of you, right? Good. So, yes, good. So, in today class, basically what we're going to discuss now, we are going to discuss the solution and colligative properties 01. What do you mean by this term? Because in previous two class, that class were basically the introduction and some important concept of class 11, right? So from this class, we are going to start this chapter, that is solution. So basically in this chapter, we are going to cover two important things. The one that is the colligative properties and the other is the liquid solution, right? So this is going to be a very, very interesting chapters and carry a very good weightage in your IIJ and NEET exam as well. So let's start with the today session. In last session, we covered till the concentration defining terms till molality. So we already covered molarity and molality, right? Everyone clear as sabko? So far we already covered molality and molarity. So in this class, we are going to cover normality first. Then we are going to discuss Raoult's law and all these things. So let's quickly see what do you mean by this term normality? Because in this chapter, in this colligative properties, we are going to use only the term molality. But the knowledge of normality is very important for you as well, right? So what is normality? So basically, we can define normality as the gram equivalent, right? As we can see here, it is defined as the number of gram equivalent weight of solute dissolved per liter of the solution, just like the molarity. What is molarity? That is the number of mole dissolved per liter of the solution. Here, instead of number of mole, here what is considered? That is gram equivalent weight. So many of you finding problem in how to calculate the gram equivalent weight, right? कि कैसे निकालते हैं gram equivalent weight, कैसे find out करते हैं gram equivalent weight. So we are going to see how we'll find the gram equivalent weight and all these things. So basically, the definition of normality is very much clear to all of you. That is, it is nothing but the ratio of gram equivalent of solid dissolved per liter of the solution. Right? Now, so what is this equivalent per liter of solution? How will you represent this? So we can represent this beta by number of equivalent of solute divided by the volume of the solution. Or we say, if someone says, just find the number of equivalent, then how will you find? Number of equivalent is nothing but the normality into volume, which is in liter. So always remember this thing. So let's see how will you find equivalent mass. Till I guess, यहाँ तक सबको clear है? Everyone? Yes? सबको clear है यहाँ तक? Good. So let's see equivalent mass. How will you find the equivalent mass? Because equivalent mass is different for different things. For example, if someone says find the equivalent mass of an acid, someone says find the equivalent mass of a base, someone says find the equivalent mass of salt. So equivalent, mass is different for different case. So we are going to see each one by in detail so that you can able to solve numerical. Either they are coming from the acidic, basic, or salt, right? So equivalent mass in general way we can define equivalent mass is nothing but that is molar mass divided by n factor, right? So this is nothing but molar mass divided by n factor. So we know that molar mass, right? Because in molality or molarity also, we are using this thing molar mass. But what is this molar mass divided by n factor? What is this n factor? So this is going to be very interesting that how do you find this n factor, right? So let's see this. So if I'm talking about the n factor, so let us assume in case of oxidizing or reducing agent. So in case of oxidizing or reducing agent, n factor is nothing but that is number of electron involved in oxidation and reduction, right? In the half reaction per mole. For example, here in this question, you can see clearly that is 5 electron, right? And this 8H plus MnO3, this will gives us Mn2 plus, right? So here we can see that total number of electron is how much? That is 5 electrons. So what is the n factor? That is 5. Let me see another example. If there is example like Mn plus 7 to Mn plus 2, right? So this is Mn plus 7 to Mn plus 2. What do you mean by this thing? Here, the oxidation state, that is oxidation is here. What takes place, oxidation or reduction? Can anyone say? Mn का oxidation हो रहा है, reduction हो रहा है, +7 to +2. There's a decrease in the charge, which is known as reduction. Good. You are in 11th class, you study this thing. So Mn +7 to Mn +2, they are converting. So what is the N factor here? So N factor is nothing but 5, right? That is number of electron. That is the number of electron involving in oxidation or reduction is known as N factor. For example, here, this is copper +2, and they accept 2 electrons, right? And become copper solid. So if someone asks, what is the number of electrons here? What is the N factor here? So you can say that 2 electron accepted by copper and reduction of copper takes place and they converted into copper. So how many number of electrons are there, beta? 2. So we can say that here N factor is 2. So in case of oxidizing and reducing agent, we consider N factor as the number of electron involved in oxidation and reduction. सबको समझ आया? जल्दी से कंफर्म कर दो एक बार, फिर आगे चलते हैं. Right? Everyone understood? Right? Yes, yes, I am waiting for response. सबको clear हो गया? Right. So this is how will you find the N factor in case of oxidizing and reducing agent, right? Okay. The next important thing for acid and base reaction, how will you find the N factor? It is very much simple. If I'm talking about the acid, right? So this is H2SO4. So in case of H2SO4, N factor is nothing but 2. Similarly, in case of HCl, we can say that N factor is what? That is 1. So we can consider in H2SO4, we have a 2H. So we can say that there is a 2H. In HCl, we have a 1H. So we can say that there is a 1. This is only the memory way to learn this thing. But actually, how will you say that there in H2SO4 N factor comes out to be 2? So this is when you actually draw the diagram. So in your 11th class chemical bonding, you draw the Lewis dot structure for H2SO4, H2SO7, H2SO8. So from that, you know the term very well, that is acidity and basicity. Let me draw and explain it to you. For example, if I draw the structure of H2SO4, right? If I draw the structure of H2SO4, what we will get? That is SO, nothing SO, and this is OH, and this is OH. So as we see, these two OH atoms are replaceable, right? These two OH group are replaceable. How will you say that? Because here oxygen and hydrogen, right? Oxygen and hydrogen having a large electronegativity difference. So this H can be easily removed. Similarly, this H can be also easily removed. So we can say that H2SO4 having basicity 2. Why they have a basicity 2? Because it converts to OH group. Right? It converts to OH group. So the basicity of H2SO4 is 2. Now, if someone asks what is the basicity in case of H2, S2 and OA, right? So if someone asks what is the basicity, so how will you find the basicity of this? Similarly, just draw the diagram like that is S double bond O, that is again S double bond O. Again, we have a S double bond O and S double bond O, right? यहाँ तक सबको clear है? Now, what we left? We have a 2s. We are using this 2s. We have a 8 oxygen. So out of 8 oxygen, 4 already takes place in the structure. So remaining oxygen is 4. And how many hydrogen we have? We have only 2 hydrogen. So only 2 OH is possible, right? Only 2 OH is possible. Now, the remaining oxygen is 8. So we have a oxygen, oxygen, and this. So this is the structure of H2SO8. Here also, how many replaceable hydrogen are there? What is the basicity of this compound? Can anyone say? What is the basicity of this compound? H2SO8. Anyone? Basicity of this particular compound, H2SO8. I'm waiting. Basicity of this compound. Basicity means what? Number of OH group. Why number of OH group? Because the number of in OH group, the removal of H is very easy because oxygen is very electronegative as compared to hydrogen. So this hydrogen can easily protonate, right? So what is the basicity of this above compound? 1, 2, or 3? right? So only two, because only two OH group are there. So only two replaceable hydrogen are there, right? So its basicity is 2. So we can say that N factor in this case is 2, right? So in this case, N factor is 2. In this case also, N factor is 2. So in case of acidic, right, acidic, we can find N factor by using or by calculating basicity. Similarly, now if I'm talking about the base, so we have a NaOH. So in NaOH, how many OH group we have? Only one group now. So N is equal to nothing but 1. In case of MgOH2, right? In case of MgOH2, so how many OH group we have? We have NH group is equal to 2. So in this case, N factor is 2. Similarly, in case of AlOH3, so in case of AlOH3, how many OH we have? So we have a 3 OH. So N factor is nothing but 3. So let us assume if someone asks you, calculate the gram equivalent weight of NaOH. So how will you calculate, beta? How will you calculate gram equivalent weight of NaOH? That is molecular mass. That is molecular mass divided by N factor. So what is the molecular mass of NaOH? That is nothing but 40. What is N factor? That is 1. So that comes out to be 40 only. Right? So I hope this is clear to all of you. Right? सबको clear hai? How will you calculate N factor for acid and base reaction? That is number of H plus ion displaced or OH ion displaced per mole of acid or base is known as N factor. Similarly for salt. So what we do in case of salt? So basically in case of salt, are we considering the total charge on cation or we say total charge on the anion? For example, in case of Al2SO4. So we know that in Al2SO4, Al having plus 3 charge, right? And SO4 having minus 2 charge. So total number of charge is what? That is 3 into 2. That is equal to 6, right? So this is how we can actually calculate this. So this is the charge on the cation, right? Because we know that Al having plus 3 charge. And how much Al, how many Al we have? We have a 2 Al. So in 1 Al, we have a plus 3. So in 2 Al, we have a 2 into 3. That is 6, right? Similarly, in case of, let us assume copper sulfate. Someone asks, what is the charge in the copper sulfate? How will you calculate the N factor for copper sulfate? So copper sulfate is also a salt. So we calculate the charge. So we know that copper having plus 2 charge, sulfate having minus 2 charge. So here the N value is nothing but 2, right? So the value of N is 2. Similarly, in NaCl, the value of N is 1 because in this cation I am having plus or minus 1 charge. So I hope it is very much clear. How will you calculate N factor for oxidizing reducing agent, for acid and base reaction, and for salt? सबको clear है? जल्दी फटाफट. Everyone? Shall we proceed? Yeah. So, let's see the next important thing, that is the concentration. Let me give one relationship as well. Can you relate this thing if I am asking you, what is the relationship between molarity and normality, right? That is the relationship, right? Relationship between molarity, right? That is the relationship between molarity and term normality, right? So how will you establish the relationship between molarity and normality, right? So we all know that. What is molarity? Let me draw with another pen. What is molarity? Can anyone? So molarity is nothing but that is number of moles per liter of the solution, or we can also write as number of mole as that is mass of the solute, right? That is mass of the solute divided by molar mass, right, into 1000 and divided by volume of solution, right? Volume of solution in ml, because we are already taking 1000 above, right? So volume of the solution in ml. Now, what is normality? Can anyone? What is normality, beta? So we already just studied about the normality. Normality is nothing, but that is mass of solute, right? That is mass of solute. And instead of molar mass, we have an equivalent mass, which is equal to molar mass upon, yes, molar mass upon n factor, right? This is nothing but molar mass upon n factor. This is similar, that is 1000 upon volume, volume of solution in milliliter, right? So this is all. Now, if you observe very carefully, we observe that this is nothing but this is molarity, right? This is nothing but this is molarity. Just look at the equation number 1, right? This is equation 1 and this is equation 2. So you can observe that this term, that is mass of the solid, molecular mass 1000 upon volume, this is nothing but the molarity. So we can establish a very good relation here. And what is this relation? That is normality is nothing but n into molarity, right? N into molarity. So this is the very, very important relationship between normality and the molarity. So if you know the n factor, right? If you know the n factor, then you can easily calculate either molarity or normality if one of them are given. Either if the molarity are given, knowing the value of n, you can calculate molarity. Similarly, if the molarity are given, knowing the value of n, you can calculate normality. And how to know the value of n, how to calculate the value of n, this I already told you, right? This I already explained to you. Let me show one example. If someone says we have a 0.2 molar H2SO4 solution, right? H2SO4 solution. Calculate normality for this. So you have to find the normality. Find the normality. So how will you find the normality of this solution? 0.2 molar. So we know that 0.2 molar means what? This is the molarity is given, right? So we know that normality is nothing but n factor into molarity. So what is the n factor in case of H2SO4? Can anyone? What is the n factor? Can anyone tell? What is the n factor? So n factor is nothing, but here in this H2SO4 we have already calculated n factor comes out to be 2. That is 2 into 0.2. So this comes out to be 0.4. So the normality of this solution is nothing but 0.4. So this is how you can actually calculate the normality if you know the molarity by using this relationship. Clear hai sabko? Anyone having any kind of doubt, you can ask better. Either you unmute yourself or just give me a chat message. I'll definitely reply each and everyone. So just ask if you have any doubt till any doubt. किसी को कोई भी doubt हो अभी तक तो please पूछो एक बार. Clear है? आगे बढ़े? Right. So the next is mole fraction, right? So what is this mole fraction? So basically mole fraction is the another very important unit, and it is a temperature independent because we know that the concentration defining terms in which mass is comes into the picture, they are totally temperature independent, right? So it is the ratio of the number of moles of the particular component to the total number of moles of all the component. So for example, we have a two component A and B, and someone say calculate the mole fraction of component A. So we can calculate mole fraction of component A by using this formula, right? By using this formula. That is the mole fraction of component A is nothing but number of mole of that component. For example, if you're asking calculating mole fraction of the component A, then the mole fraction comes out to be number of mole of A divided by number of mole of A plus number of mole of B, right? Similarly, for the binary mixture, we know that in binary mixture, we have only two component, either component A, component B, or any two component only, right? So for the binary mixture, we can calculate mole fraction of solute and mole fraction of solvent comes out to be 1. So if you know the mole fraction of the one component, we can calculate other by just subtracting from -1, right? So this is how will you calculate the mole fraction, and it is temperature independent quantity, right? Now let's move to the next concentration defining term. So this is also important. That is parts per million, right? So this is the parts per million. So basically the number of parts of the solute present in 1 million parts of the solution are called ppm. Just like a mass percentage, mass by volume percentage or volume by volume percentage. So in case of a percentage concentration defining term, we are using out of 100 only. That is 100 में से कितना present है? Out if they are giving 20%, it means there are 20 gram out of 100 gram. If they are giving 20% volume by volume, we are saying 20 ml out of 100 ml. But in case of ppm, that is 1 parts per million. Basically, this term is used to represent those quantity which are present in a very, very small amount. For example, in atmospheric pollution, right? So these things are actually represented in the parts per million, right? So when the solute is present in a small quantity, that is very minute amount, it is easier to express the concentration in the parts per million instead of mass percentage. So this is the needs of parts per million, right? So here we see the some formula for this parts per million. So we can say that if we're talking about the weight by weight, so we can say that weight of the solute upon weight of the solution into 10 raised to the power 6. Similarly, ppm by weight by volume. So we can say that weight of the solute in gram upon divided by volume of the solution in milliliter into 10 raised to the power 6. So instead of 100, here we are using 10 raised to the power 6, right? Because we are talking about parts per million. Clear है सबको यहाँ तक? Right? So this is what ppm. Now, this table is very, very much important because from this table, actually you differentiate all the concentration defining term. Now, let's start with the molarity. We already studied all this thing in a very, very detailed way. So let's explore their, differences. So if I'm talking about the molarity, so basically what is the unit for molarity? Because molarity is defined as the mole per liter of solution. So this is the unit mole per liter. Now, what is the advantage of using molarity? So they are useful in stoichiometry and measured by the volume. So they are very much useful in stoichiometric calculation, and they are also measured by the volume. What is disadvantage? They are temperature dependent, and you must know density to find out the solvent mass. So one limitation is they are the temperature dependent. So the case in which we are talking about the temperature changing, where we cannot consider molarity, right? Because in colligative properties like elevation in boiling point, depression in freezing point, we deal with the temperature. So in such case, we are not considering molarity. Instead of molarity, we are going to consider molality, right? So we are going to consider molality only. So this is all about the molarity. Now, what is mole fraction? So basically the unit of mole fraction is nothing. They are the unitless. Why? Because mole fraction is the ratio of number of mole of the solute upon my total number of mole. So mole by mole, they are the unitless, right? Now, they are temperature independent and useful in the special application, just like the colligative property. They are measured by mass. So must know density to convert to molarity. Okay. Now, the next important concentration defining term is mass percentage. So basically unit of mass percentage is percentage as they indicated, and the advantages is that temperature independent quantity and useful for the small amount. Measure by mass, must know the density, right? So you always know the density to convert this. The next is the molality. For the molality, you have to know the mole of the solute per kilogram of the solvent, and this is also a temperature independent, right? Now, one important note here, beta. This one is very, very, very important note. That is all the volume related concentration terms are temperature dependent, right? All the volume related concentration terms are temperature dependent. So this is the very, very important note in terms of concentration defining term, right? So I hope this is clear to all of you. जल्दी बता दो एक बार बेटा, सबको क्लियर हो गया ये? Everyone? If you have any kind of doubt, beta, you can ask, right? No? Okay. So this is the difference between the molarity, mole fraction, mass percent, and molality. So they are the advantages and disadvantages of these things, right? So I hope this is clear to all of you. Good. Now let's see some numerical and try to solve a question based on this topic only, right? So let's see some numerical. So we have a first numerical. In this, the data is given. Like if we have a 10 molar urea solution. So remember one thing, 10 molar and 10 molar, right? So there is a difference between this term molar and molar, right? So if the molar is given, right, molar, M-O-L-A-R, molar, then this is molarity. If the molar is given, then it is a unit of molality. So always remember this thing, small things. Otherwise, you face a problem in solving numerical, right? So in this question, if you have a 10 molar urea solution, calculate the mole fraction of urea in this solution and also calculate percentage weight of urea, right? So now we want to calculate what is the first, that is mole fraction of urea. So can anyone give me the idea? What is the formula? How will you calculate the mole fraction of urea? We just talked about the mole fraction. That is how will you calculate the mole fraction, right? So we have to calculate the mole fraction of urea. So the mole fraction of urea is nothing but number of mole of urea, right? Number of mole of urea upon में number of mole of urea plus number of mole of water. This is what we have, right? Because mole fraction is nothing but the number of mole of that component, right? Whose mole fraction you want to calculate. So it is equal to number of mole of urea divided by my total number of mole, because this is the binary solution of urea and water only, right? So this is what. Now in this question they are given 10 molar. What is this 10 m? So 10 m means 10 moles. 10 moles of urea. 10 moles of urea, right? In how much? In how much? That is, what is the mass of solvent here? So this is the 10 mole. So this is the 10 mole of urea in 100, or we say 1000. Yes, in 1000 gram of salt. Always remember this, right? So this is the 10 moles of urea in 1000 gram of the solvent. So here the number of mole of urea is very much clear, that is equal to 10 mole. Now, if the number of mole of urea is given 10 mole, here we can also consider this. Now, what is the number of mole of water? So we all know that number of mole of water means what? Can anyone? We can calculate number of mole of water now, basically. How will you calculate number of mole of water? Number of mole is nothing but mass upon molar mass, right? Mass upon molar mass. So here we can observe that what is the mass? So mass is nothing but the 1000 gram of solvent we are using, right? The solvent is nothing but 1000 gram, and solvent is here is what? Water. So that is nothing but 1000. And what is the molar mass of water, beta? That is 80, right? So this is how will you calculate. So just solve this value, you will get 10, and this is 10 upon 55.5. That comes out to be 65.5, right? So this is 65.5. 65.5. So just solve this, you get the value like 0.1526. And this is the unitless quantity, right? So there is no unit, because the mole fraction, number of mole divided by the total number of mole. So the same unit are dividing. So we can say that this is a dimensionless, or we say unitless quantity, right? So this is how will you calculate the mole fraction of urea. Anyone having any kind of doubt till? How will you calculate this? कुछ भी doubt हो, you can ask. You can ask, beta, if you are facing any kind of doubt till. No? Okay. Now, the next thing is, this is the first thing. The next thing in this question, they are asking to calculate the percentage weight of urea, right? So we have to calculate the percentage weight of urea. So how will you calculate, beta, percentage weight by weight? So we know that weight by weight is nothing, that is the mass of the solute divided by the molecular mass, right? So this is how we can calculate. So we can percentage weight, we have a formula for the percentage weight, that is the mass of the particular component that you want to calculate. For example, if you want to calculate the mass of the what? Mass of the urea. So this is the mass of the urea divided by total mass of the solution. Total mass of solution multiply by 100. So this is how will you calculate the percentage weight. So can anyone tell me what is the mass of urea in this case? Can anyone? Mass of urea. Anyone? Mass of urea. Mole of urea is already given. Can you calculate mass of urea using mole of area? Have any formula for this? Yes, we know that. We already calculate now for water. So on the similar basis, mole of urea is nothing but the mass into molecular mass, right? Divided by molecular mass. So we can calculate mass of urea as number of moles of urea into molecular mass. I hope this is right. So what is the number of mole of urea? That is 10. What is molar mass? That is 60. So this comes out to be 10 into 60. So that is 10 into 60. What is total mass? So total mass of the solution means mass of urea plus mass of water. So this is how we will calculate. So we know that mass of urea is what? That is 10 into 60. Okay. And what is the mass of the solvent? That is nothing but 1000. So just on solving, that is the 10 into 60, that is the 600 divided by 600 plus 1000. That is 1600, right? So this will comes out to be into 100 also we have. So on solving, what you'll get 37.5%. 37.5%. So this is how will you get the percentage weight by weight. So in this question, they are asking two things. That is calculate the percentage weight by weight and the mole fraction. So by knowing the concept, by knowing the concentration defining term, we can easily calculate this thing. So I hope this is clear to everyone, right? Anyone want to ask anything in this question? You can ask. Raise your hand. You can ask. No? सबको समझ आ गया? चलो. Now, the next question is also very much similar to the first question itself. So let's see the solution of this question also. So what the question asks? In the example 2, basically calculate molarity of calcium carbonate solution which has a concentration of 200 ppm. So here in this question, concentration is given. Concentration of calcium carbonate is given, which is equal to 200 ppm. And now you have to calculate the molarity of calcium carbonate aqueous solution, right? So how will you calculate this term molarity? So basically we know that for molarity, what we need actually. So for molarity, the basic need is nothing but the number of moles divided by 1 liter solution. That is volume of 1 liter of the solution. So this is the basic need, right? So if someone want to calculate the molarity, they must know the number of moles and 1 liter of the solution. If you know these two values, then you can only able to calculate the molarity. We can further express number of moles as mass of solid upon molecular mass into 1000 upon volume. So this is the formula of molarity, right? Now, in this question, the solution having concentration 200 picometer. So what do you mean by this term 200 gram of picometer? Can anyone tell me? 200 gram of calcium carbonate. What do you mean by this term? 200 ppm. अभी बात किया था ppm का हमने. So इसका मतलब क्या हुआ? इसका मतलब हुआ अगर यहाँ पे लिखा होता 200%, then what their meaning? That is 200 gram present in how much? Yes, it means 200 gram. So 20 gram, 30 gram present out of 100 gram, right? So this is called 200 ppm. So 200 ppm means what? 200 ppm means 200 gram of calcium carbonate. Okay, 200 gram of calcium carbonate in 10 raised to the power 6 gram of water. समझ आया सबको? What do you mean by this 200 ppm? So 200 ppm means 200 gram of CaCO3 in 10 raised to the power 6 gram of water. So can you calculate the number of mole? Anyone? How will you calculate the number of mole? Yes. So we can calculate number of moles of calcium carbonate. So what is the number of moles of calcium carbonate? That is mass of the solute upon molecular mass. That is mass of solute, or we say calcium carbonate, divided by molar mass. Right. So let's calculate the molar mass of CaCO3. We know that for calcium, molecular mass is 40, for carbon 12, and for this oxygen, we have a 16. 16 is 48. So 48 plus 250, 10, 60 plus 40. It comes out to be beta 100. Right. So this comes out to be 100. And what is the mass? So this is the 200 gram of mass. So this is 200 upon 100. So this comes out to be 2. Right? So this comes out to be 2. So what is this is the number of moles actually, right? This is the number of moles. So what is the molarity? So put the value in equation 1. So put in equation 1. What we get? We get molarity is equal to number of moles, which is equal to 2. And this is 1 liter of the solution. So we can write as 10 raised to the power 3. So we can get 2 into 10 की power minus 3. So this is the molarity of this solution. Anyone? सबको समझ आया यहाँ तक? Anyone having any kind of doubt till? You can ask. Clear है सबको अभी तक? How will you calculate the molarity of the CaCO3 in the solution which has a concentration of CaCO3 200 picometer? सबको clear है? Right? Okay. Okay. Now, let's move to the next thing. Right. So try to solve this question. What the question asks basically, a 6.90 m solution of KOH in water has 30% by weight of KOH. Calculate the density of the solution. So you have to calculate the density of this solution. Can you calculate the density of this solution? Can anyone? A 6.90 molar solution. What do you mean by this term? 6.90. Anyone wants to say anything? 6.90. What do you mean by this term? A 6.90 capital M is given. If the small m is given, it means 6.9 mole out of 1000 gram of the solvent. Now, what do you mean by 6.90 molar? Guys, this is molar, capital M. Anyone? बोलो. तुम लोग भी बोलोगे तो इंटरेक्शन रहेगा, गुड रहेगा. इससे तुम अपने डाउट क्लियर कर सकते हो. इट्स नॉट नेसेसरी कि मैं पूछूं तुमसे, है ना. तुम लोग कोई भी डाउट हो, यू कैन आस्क. ओके, सो दैट वी कैन make this class more interactive. Okay, so a 6.90 m solution. What do you mean by this thing? 6.90 m. So 6.90 m means 6.90 mole in, ठीक है, 6.90 mole in 1000 ml of solution, or we say 1 liter of the solution. You can say anything, right? So 6.9 m means 6.90 mole in 1000 ml of the solution. Now they are saying in water as a 30% by weight of KOH. So out of this, 30% by weight of KOH is already present, right? So what is the calculate the density of the solution? So for calculating density, what we must know? If you want to calculate the density of the solution, right? Yes. Yes, you can ask Rupra. You want to ask anything? You can ask. No? Okay. So basically, density of the solution, right? Okay, I have a message. No, sir. Good. So, if you want to calculate the density of the solution, right? Density, density of solution. Can anyone tell me how to find the density of the solution? Density is what? Mass upon volume. So, density of solution is nothing but mass of solution. Remember this thing. Mass of solution divided by volume of the solution. Volume of the solution. So we know the volume of the solution is nothing but is equal to 1000 ml, right? We already know this thing. That is the volume of the solution is nothing but the 1000 ml, right? If you want to consider this is in ml. Now, what is the mass of the solution? How will you calculate this mass of the solution? So in this question, it is already given that 30% by weight of KOH. So in this solution, we have a two binary solution of KOH in water, right? So we have a KOH and water. So we know that KOH, this is only 30%. 30% means what? 30 gram, right? And water is what? That is 70 gram. So if I'm talking about the mass, so what is the mass of the solute is 30, mass of the solvent is 70. So what is the mass of the solution? So mass of the solution comes out to be 30 plus 70, that is 100 gram. So this is the mass of solution. So mass of solution is nothing but it is equal to 100 gram. Okay. So density. So here the mass of the solution is 100 gram and the volume of the solution, right? And the volume of the solution is what? Can anyone? What is the volume of the solution? That is 6.9 molar solution of KOH in water at 30% by weight. What is this 6.9 molar solution of KOH? What do you mean by this thing? 6.90. So can you calculate the weight of the solution by this? Yes, we can calculate. How? Because we know the mole, right? We know the number of mole. So number of mole is equal to mass divided by molar mass, right? Divided by molar mass. So we can calculate mass just by multiplying number of mole into molecular mass. So number of mole is already given, that is 6.90. And what is the molar mass of KOH? K, we know that K we have a potassium, we have a, how much? That is K having atomic number 19. So this comes out to be 38, right? So this is 38. This is oxygen we have 16 and hydrogen we have 1. This comes out to be how much? 38 plus 16 plus 1, that is 17. So it comes out to be 56, right? So this is nothing but 56. So 6.90 into 56, right? 38, 39, 39 and 16, 39, 59, right? So this comes out to be 56. So just multiply this thing. So you'll get the weight of the solution, right? So this is how will you get the weight of the solution. So this is what weight of the solution? 6.90 into 5.6. Now, 6.90 m solution of KOH water has a 30% by weight. It means the mass of these lie only 30% of this. So for this value having only 30%, it means this is equal to 100 divided by 30. So just calculate the mass from this. So mass comes out to be, and for the density, we know get the mass of the solution. Mass of the solution is what? That is nothing but 6.90 56 into 100 divided by 30 in the volume of the solution, that is equal to 1000 ml. So you can just calculate, right? So you can calculate. So on calculating, it comes out to be 1288 gram per liter, or we say per milliliter, if you're considering in milliliter, right? So this is how will you actually calculate this. I hope you got this. What the question asks, basically 6.90 molar solution. So it is very much clear from this line only. 6.90 molar solution means what? 6.90 mole out of 1 liter, right? So 6.9 mole. So if you know the number of mole, we can easily calculate mass, because by using this formula, we know the mole, so we can calculate mass. Molecular mass we know 56, so this is the mass. Now in this question, has 30% weight of by KOH. What do you mean by this? Then is this mass having only 30%. So just calculate the 30% for this. So multiply 100 by 30. Now just put the value. So you'll get the density of the solution. Right. So this is how will you get this. Okay. The next question. The density of the 3 molar solution of Na2H2O3 is this. Calculate the percentage by weight of Na2H2O3. And the second is the mole fraction of Na2H2O3. So how will you calculate this thing? Let's start. The first one, you have to calculate the percentage weight by Na2H2 and O3. So how will you calculate, beta? Can anyone try? So just try this. This is a homework question for you all. Just calculate this, right? If you face any problem, then we'll discuss. I'll discuss the solution in the next class for this question, right? So this is the homework question for you all because we have to complete some more topics in the today class. That's why I'm giving this as a homework question. So it's a very simple question. Density of the 3 molar solution is given. You have to calculate the percentage weight, right? Just calculate the percentage weight. So for the percentage weight, what you need? Mass of the solute, mass of the solution into 100. So mass of the solute you can calculate from the 3 molar solution, right? 3 molar means 3 mole in 1 liter. So if you got the number of mole, right? So you've got the number of mole. This is mass. Let me solve one question for you so that you can solve the rest one. And this is the molar mass, right? This is the molar mass. So if you want to calculate the mass, that is nothing but 3 mole. And the molar mass of Na2H2O3. So just calculate the molar mass of Na2H2O3, put the value. You'll get the mass. Now percentage weight. Mass divided by mass of the solution. From where you will calculate the mass of the solution? That is density. Because density is already given. Nah? Density is equal to what? That is mass of solution divided by volume of the solution. So you know the density in this question. You know the volume as well because already 3 molar solution means 1000 milliliter. So you know the density, you know the volume 1000 ml. So you can easily calculate mass of the solution. So just put the value of mass of the solute divided by mass of the solution into 100. You get the percentage weight of Na2SO4. And similarly, you get the mole fraction as well. Right? So this is how we calculate. So this is the homework question for you all. Try to solve this question. Okay. Now, so after completing the concentration term, the first important thing that we are going to study is that the Raoult's law. So we have a Raoult's law for the 2 cases. In today's class, basically, we are going to discuss the Raoult's law for a volatile liquid mixture. In the next class, we are going to discuss the Raoult's law for the non-volatile solute, right? Non-volatile solute in colligative properties we are going to discuss. So what is the Raoult's law? What is the statements of Raoult's law? So basically, Raoult's law state that in solution of volatile liquid, what do you mean by this term volatile? Can anyone explain? What is this term volatile? Volatile means, what is volatile? Having tendency to convert into the vapor more easily, right? So this is known as volatile. Liquid have a strong tendency to volatile where the solid have a least, right? So we can say that in solution of a volatile liquids, the partial vapor pressure of each component is directly proportional to its mole fraction. So this is the statement of the Raoult's law. That is the, in case of volatile liquids, the vapor pressure of each component, right, is directly proportional to the mole fraction. If I'm talking about the 2 component, let us assume we have a 2 component, right? This is the component number 1. We have a solvent, right? This is the solvent. And let us assume this is the solute. So this is the component number 1 and this is the component number 2. So if you want to calculate the pressure of the component A, or we say PA, so this is directly proportional to mole fraction, that is XA. Similarly, if you want to calculate the mole fraction of PB, then this PB is proportional to mole fraction of B. Or we can say that PB comes out to be XB into P naught A, right? So this is how will you calculate the partial vapor pressure. So this is the statement. So where PA stand for the partial pressure of the component A, XA represent the mole fraction of the component A, and P naught A represent the vapor pressure of the component A at the given temperature, or we say in pure state, right? So how we'll derive the total pressure over the solution using the Raoult's law and Dalton's law. So let's consider A and B. So A and B be the two volatile liquids in a closed container, right? So in this case, now the solute and the solvent both are liquid. So this is called liquid-liquid solution. Liquid-liquid solution, because both in this case, solute and solvent both are liquids. So let A and B be the two volatile liquids in a closed container as shown in the figure. So A is represented by this dark circle and B is represented by this cross sign, right? So this is AB, AB. Now, what is the partial pressure of A? We already know PA is equal to XA into P naught A. Similarly, for the liquid B, we have a partial pressure B is equal to XB into P naught B. So, according to the Dalton's law, we know that what is the total pressure? Total pressure is the sum of the individual partial pressure. So, we can say that PT is nothing but is equal to PA plus PB. And PA and PB in terms P naught A XA plus P naught B XB. So, this is the total. This is the total pressure. So just remember this word here, very important thing. That is the total pressure comes out to be P naught A into mole fraction of that component, P naught B into mole fraction of that component. So this PT is equal to P naught A XA, P naught B XB. So this is all about, right? Now, determining the composition of the vapor phase. So let YA, or we say if you want to calculate the composition in the vapor phase, right? So this is the composition in the liquid state. Now, if you want to calculate the composition in the vapor state, so we are considering in case of XA, we have a YA. YA means mole fraction of A in the vapor phase above the solution. And YB is the mole fraction of the B in the vapor phase above the solution, because they are the volatile liquid. So their vapor will be formed. Now we want to calculate their mole fraction at vapor phase, that is YA and YB. Now we can easily calculate this, right? So how will you calculate this, beta? Can anyone tell me? Wait. Right. So can anyone tell me how will you calculate this in case of vapor pressure? Anyone? In case of vapor, right? So in case of liquid, we calculate this PT is equal to P naught A into XA, P naught B into XB. How will you calculate in case of the vapor phase? Can anyone? Yes. So on the similar basis, just like a liquid state, we can also calculate it in vapor phase, right? So let's see if we want to calculate for the PA, right? So this PA is equal to nothing but mole fraction in the vapor phase, that is YA into total pressure. Similarly, if you want to calculate for PB, you can write as YB into P, right? Now, we know that Dalton's law of partial pressure according to this. So how will you convert this? So this is nothing but PA into mole fraction in the, yes, that is a vapor phase, right? And this. So you can calculate. Similarly, for PB, you can calculate this is YB into P. Okay. So what is the total pressure? Can you calculate the total pressure? Yes. So just like this phase, we can also calculate this is equal to PA plus PB. So just put the value, you'll get this, right? So this is how will you calculate in case of vapor pressure as well. Just remember in terms of XA and XB, we are using YA and YB in this case, right? So this is all about the determination of composition in the vapor phase. Okay. So I hope this is clear to all of you. So I hope this graphical representation of Raoult's law, this we are going to discuss in the next class, because the time is already, completed. So this thing we are going to be considered in the next class, going to discuss in the next class. Till I request you, all of you, just revise the whole thing, right? We already cover all the concentration defining term, molarity, mass percentage, right? And the ppm, that is parts per million. So this already we completed. To try to solve numerical from your module till this topic, that is the concentration defining term. In the next class, we already cover this Royle's law, ideal, non-ideal solution, and some colligative properties as well. That is in tomorrow class, right? So in tomorrow class, we are going to discuss all about the Royle's law, ideal, non-ideal solution, what is the difference between them, graphs between azeotropic mixtures, and also try to cover some colligative properties, right? So till just revise this thing, and you have any doubt till you can ask. If you have any doubt, you can ask just or you can chat, you can just give me a message, right? सबको समझ आया? किसी को कोई इशू नहीं है? क्लियर है यहां तक सबको? एंड करें क्लास? चलो ठीक है. So take care. Let's meet in the next class where we'll discussing about the someone having, I guess, no. Okay. So just take care all.